Hello everyone. In the last session we discussed the introduction part of refraction of light. Now in this video I am going to discuss about laws of refraction of light, or which is also called as Snell's law of refraction of light. So what is refraction of light? The phenomenon of bending of ray of light when it travels from one medium to another medium of different optical density. So when the ray of light is traveling from rarer to denser or denser to rarer, speed of light changes so that bending phenomenon takes place, and this phenomenon we can call it as refraction of light. What is the cause of refraction of light? So you should remember, the refraction of light takes place only because of change in the speed of light. When speed of light changes, then refraction of light takes place. Now, why the speed of light changes? Because of different optical density. So that is, when it is traveling from lower density to higher density or higher density to lower density, speed of light changes, bending of light takes place, and this is refraction of light. Now, we can move towards laws of refraction of light. There are two laws of refraction of light, and the second law of refraction is called as Snell's law of refraction. State Snell's law means you should write second law of refraction of light. Yes, first we can move towards the first law of refraction of light. What is the statement? The incident ray, the refracted ray and the normal at the point of incidence all lies on the same plane. So you can observe the diagram: incident ray, refracted ray and normal. These three lines are drawn at the point of incidence lies on the same plane. So this plane we can call it as interface. This is first law of refraction of light. Now, the second law of refraction states that the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. That is, sine I divided by sine R equal to constant. So sine, it is a trigonometric function, and I indicates angle of incidence, R indicates angle of refraction. So here we are going to consider the trigonometric function sine. Sine of angle of incidence to the sine of angle of refraction remains constant, and that constant is called refractive index. Trigonometric function sine we are using only because when we are going to measure the angles, you can observe angles are measured between normal, interface and ray of light. These three lines we have to consider whenever we are going to measure the angle. So what happens here? When we are going to measure the angle, so this trigonometric function appears. So according to the mathematician Wilbrod Snell, it is just a convention, just like a Cartesian sign convention as we studied, which is positive and negative in reflection of light. Likewise, it is just a convention to choose the angle between normal, ray of light and interface, so which makes this function to appear. And these angles are easily demonstrated using exactly these principles. So that means we can say that we are using this trigonometric function sine only because this function is suitable. So that's why the equation is sine I divided by sine R equal to constant, and this constant is called refractive index. Second law of refraction of light is also called as Snell's law because this law was discovered by the mathematician Wilbrod Snell. Now according to Snell's law, we have the equation sine I divided by sine R equal to constant, and this constant is called refractive index and it is denoted by N. Then what is refractive index? Refractive index measures velocity of light in the given medium. That means speed of light is changing from one medium to another medium. So that speed of light is determined by refractive index and it is denoted by n. Observe this ray diagram. So let us, the ray of light is traveling from medium 1 to medium 2. Medium 1 is having refractive index n1, medium 2 is having refractive index n2. Remember, n1 and n2, that indicates speed of light in medium 1 and medium 2 respectively. Now here, when the ray of light is traveling from medium 1 to medium 2, automatically speed of light changes, bending phenomenon takes place. Then how to write refractive index? We know that refractive index is denoted by n. But now it is traveling from n1 to n2. So now we can write it as n21 or n2 divided by n1. How to write refractive index? n21. That means refractive index of second medium with respect to first medium, or it can also be written as n2 divided by n1. So now the question is, why we have to write n2 in the numerator? Why we have to write second medium first? Only the reason is speed of light changes in second medium. You can observe initially the ray of light is traveling in medium 1. In medium 1, speed of light is constant. It is having a uniform density. When it enters another medium, speed of light changes. Where the speed of light is changing? Speed of light is changing in second medium. So always we have to write second medium first, then first medium. That is n21. n21 means refractive index of second medium with respect to first medium, or n2 divided by n1. Now from the Snell's law we have the equation sin I divided by sin R equal to constant. That constant is refractive index. How to write refractive index? n21 or n2 divided by n1. Cross multiply here. n1 sin I equal to n2 sin R, and this equation is called generalized Snell's equation. So which is the generalized Snell's equation? n1 sin I equal to n2 sin R. n1 is refractive index of first medium, n2 is refractive index of second medium, and I indicates angle of incidence and R indicates angle of refraction. So this is very important concept. So while solving the numerical problems, this is the important equation. So please remember, refractive index of second medium with respect to first medium can also be written as n21 or n2 divided by n1. So the equation is n1 sin I equal to n2 sin R. This is generalized Snell's equation. Now absolute refractive index. What it mean? It is the ratio of refractive index of vacuum to the refractive index of given medium. It means they are going to consider speed of light in vacuum with respect to speed of light in any given medium. So why we have to consider speed of light in vacuum? Because speed of light is constant in vacuum, and that is 3 into 10 raised to 8 meter per second. And the speed of light changes when it enters any other medium. So the equation is n equal to c divided by v. N indicates absolute refractive index, c indicates speed of light in vacuum medium, and v indicates speed of light in any given medium. So this is absolute refractive index. So this is all about two laws of refraction of light. What is the first law of refraction? That is incident ray, refracted ray and normal at the point of incidence lies on the same plane. That is first law. Then what is the second law? It is the ratio of sine of angle of incidence to the sine of angle of refraction remains constant. This constant is called refractive index. Refractive index is denoted by n, and what it measures? It measures speed of light in the given medium. And which is the generalized Snell's equation? n1 sin I equal to n2 sin R. So this is all about the two laws of refraction of light.